Hello, welcome back to MTHPT 137. One of the things that we used a little bit in the previous chapter, and we're going to use a ton in chapter 12, and we'll use it in 13 and 14 as well, is this idea of significant digits. So I want to go ahead and go over the rules if you didn't take the time to look them up. So the rules are every digit that is a non-zero digit, in other words the numbers 1 through 9, are automatically considered to be significant, so you don't have to worry about those. It's the 0 that has rules on sometimes it is and sometimes it isn't. So if a 0 lies between two non-zero numbers, then it is a significant digit. So in this case the 0 is lying between the 3 and the 7, so 0 is significant. Therefore, the number 307 has 3 significant digits. If zeros lie to the right of a decimal and the significant digit, then they are also significant. So in 0.860, the 0 here is to the right of the decimal and a 6, which is a significant digit, which makes 0 significant. In 860.00, this 0 is to the right of the decimal and a significant digit, making it significant. Therefore, numbers that are between them are also significant, or zeros that are between them, I should say. Zeros, if they are to the left of a significant digit, then they do not count. So 0.0, it would need another significant digit on the left-hand side of it in order for it to count, so it only has 2. Same with this one, the 0 is to the left of significant digits and does not have another one, so it does not count. If you want to make a number significant but not use decimals or other numbers, you can put a bar or a tilde over the top of a 0. That tells the person that you're communicating with that 0 is significant. And since this 0 with the bar is significant, then the 0 between the 0 with the bar and the 8 is also significant. Now, one thing about significant digits is that it is a tool for communication. So we're only using it because we can't have a verbal conversation with somebody and they need to be able to look at our answers or on given numbers and be able to be as accurate as we were. So that's their goal. This first one, we have 5 pieces of metal with 5 different weights, and we're going to add those up. So I'm going to take a moment to do that. 38.85 plus 950.8, 6.536, and 43.865, and 0.0974. So those numbers add up to 1040.1484. Okay, now you might be like, okay, do I just leave the number as is, or what do I do? So when you're rounding an answer, you can only round to the same accuracy as the numbers previously. So 3885 are all significant digits, so we have 4 of them. 950.8 does have a 0. That 0 is between a 5 and an 8, which are significant, so that makes the 0 significant. So this has 4 significant digits. 6.536 are all significant, there's no zeros. Same with 43.865, but since there are 5 of them, it has 5 significant digits. On this one, the zeros are to the left of significant digits, so they do not count. So we have the 9, the 7, and the 4 that are significant, so this one has 3. So we have 3 numbers with 4 digits of significance. We have one with 5 and one with 3. You can't be more accurate than the least amount. So the 3 is the least amount of precision, so we're going to use that. So we're going to count in 3 numbers, and we always count in from the left. I think of it just like reading a book. We read from left to right. So we're going to count in 1, 2, 3. The 0 behind the 4 is the number we look at to see if we round up or round down. 0 says to leave the 4 alone, so it would be 104. Now if all we did was write those 3 numbers, we changed the value of the problem. It would become 104, not 1040, So we do put a 0 after the 4 to keep the value in the thousands, but the 0 to the right is not significant because it doesn't have a decimal and other significant digits. So this number really just has 3. The 1, the 0 between the 1 and the 4 are the 3 significant digits. Okay, so let's look at some other numbers to practice this rounding idea. So I have 9050.8, and first it wants us just to round to 2 significant digits. So the 9 and the 0 are the 2 they want us to round to. So we look at the number behind it, which in this case is the 5. 5 says to do what to 0? It says to move it up. So that 0 will become a 1. So it's 91, but I don't want it to be 91 because that's a totally different value than 9,000. So I need it to stay in the 9,000s, so I put zeros here. Since zeros are the only number that is not always significant, those are the only numbers I can use to hold value. And so this has 2 significant digits, the 9 and the 1, and it's rounded to 9100. If I look at the next one, this one wants 3 significant digits, so the 9, the 0, and the 5. So I look behind the 5, which is a 0. 0 says to do what to the 5, which leave it alone. So I have the 9, the 0, and the 5. If I just leave it like that, it changes it to 905, which is not the value of the number. So I'm going to stick a 0 at the end, which does not change the significant digits, but it does keep it in the 9,000s. So then I have one more to practice here. This one is 4 significant digits, so the 9, the 0, the 5, and this last 0. 8 says to move the 0 to a 1, so it's 9051. The 9 is in the thousands place, so I don't have to add any extra zeros, and I'm done. And it has 4 because the 0 between them is significant. Now you can see the more significant digits you have, the more accurate the number is, because 9051 is the closest option to the 9050.8. So the more significant digits, the more accurate it is. Now I have one more for you here, and I tend to use a black screen because I get headaches, so I'm going to change that page color. I just want you to be able to see it better. Okay, so we have a triangle here, and it asks us to find perimeter and area, which is a good practice because we're starting into the geometry chapter. Before I can do perimeter, well actually let's go ahead and do area first because we have everything we want for that. So the formula for, oops, I need my pen back. Sorry, I don't know why that went away. I need my pen back. There we go. Let's make that go away. Okay, we're back to where we were. Sorry about that. Okay, so formula for area of a triangle is 1/2 base times height. So this would be the base and this would be the height. So we would plug into our calculator 1/2 times 9.11 times 3.45. So for area, I get 15.71475. Okay, so this is area is based on significant digits. So we look at the numbers that were given to us. 345 has 3 significant digits. 9.11 has 3 significant digits. So that means you want to round your answer to 3 significant digits. So 1, 2, 3. We look behind it. 1 says to leave the 7 alone. So our answer for area is going to be 15.7, and I don't have what the units are. So we're just going to leave it at 15.7. So I was as accurate as the numbers that were given. Now to find perimeter, we're going to use Pythagorean theorem, and I'm going to do it quickly because that's not our focus here. Our focus is significant digits. So 3.45 squared plus 9.11 squared, and I need to square root that. So this side, C, is 9.7413 and some other numbers. Okay. Perimeter is when you add up all the numbers. So I'm going to add that number to 3.45 and 9.11. So my perimeter is 22.3013 and some more numbers, and that's a decimal. Okay, perimeter is different than area. Area is significant digits. Perimeter is the accuracy of the numbers that are given in the problem. So by that, what I'm saying is that, I'm going to change colors, see if that helps. The 5 is 2 decimal places is 2 numbers after the decimal place. The 1 is 2 numbers after the decimal place. So when you're doing perimeters, and this would also count for circumference when we do circles, you go 2 numbers after the decimal place. You do not look at significant digits. So 2 numbers after the decimal place would put us at the 0. 1 says to leave the 0 alone, so the answer for perimeter is 22.30. Now when you're working on your answers, if you're thinking it might be a rounding issue is why WebAssign is marking them wrong, please hit the Ask Your Teacher button and send me a quick note. I can quickly verify as soon as I get back to the computer if it is a rounding issue or not. That way you're not spending 2 or 3 tries waiting for it to be, you know, a non-rounding issue, especially. Okay, so definitely keep that in mind and communicate with me so you don't get frustrated. Okay, I will be back with the next video. Have a good day.